we know it's a circle. Just make it clear, and it's expanding. Okay. We want to know what's the rate of change at this point, I think. When the radius is 176, right? So the idea for all these word problems is you have to know the formula, which is the area formula. And if we wanted to find the rate of change for area, we do the derivative.
I want to explain what the dt means.
That's area with respect to.
Yeah, okay. This is area with respect to time. Yeah, you guys got that? Okay. So,
That's given. Those two
yeah,
things are given.
yeah, these are given.
All right.
So we have the form. This is like the golden rule, man. You don't have this, you can't do anything with this.
All right.
We find the derivative of this function. So we find the derivative of a,
Oh.
dA dt,
Yeah.
because of respect to time. Then we find the derivative of r, which is dr dt, but you bring down the 2, so it's 2r. Pi stays the same. If you want to bring the constant to the front, you can, which they did here. So we have this. We know what r is. R is 176, right? So you change it. The 2 in the front, 2 pi. Why is this a 2? Because we're given dA dt equals 2. Alright? So what we're looking for is the rate of change, at this particular point. So we want to solve for this. So we take this to this side. They take something. It's just algebra. Just algebra. Yeah, it's just algebra. Yeah, you divide it. And then you plug in the calculator here, and you get this answer. You guys got that? You guys don't understand how to stand here. That was really easy. So anytime you take the derivative of like this function, it will be dA over dt with respect to time.
Alright, 31.
You guys got it?
Yeah, reread the question first,
Yeah.
that way everybody knows
Yeah.
the concept. 31.
31. Water is being drained from a container which has the shape of an inverted right circular cone. The container has a radius of 9 inches at the top and the height of 10 inches. At the instant when the water in the container is 8 inches deep, the surface level is falling at a rate at 1 inch per second. Find the rate at which water is being drained from the container. Okay, so they want to find the water, the rate of change, the volume change, which is it. That's the rate of change. Okay, so we're given this. I really have to explain it. This is the picture. We're given the radius of the cone, which is 9. We're given the height, is 10, and we're given the depth at a certain point, which is here, 8 inch. Let's just say this is 8 inch, 8 inch deep. At this point, we know the rate is changing at 1 second. I mean, 1 inch per second. And then that's respect to height. You see it? It's the change of the height, respect to the time.
And that was from the question, right? Kind
So this is equal to 1. You see it?
Yes.
You're going to have to remember. First, we want to find, we have the golden formula. This is really important.
That's what we find.
Yeah.
That's the formula
Yeah, we're gonna find
volume
this,
of a
but we
cone,
use
right?
this. So we're given, but we have to find r. We know in trigonometry, this is a right triangle. And it's proportional, 9, 10, and it comes down here. I wish you guys can see it.
Oh, that's the similar triangle form.
Yeah, and this is right up here. 9, 10, right? We don't know r here, right? But we're given 8. So we know that this is 8 with respect to r.
Yeah.
You see it?
Yeah.
No, how it's all over h.
72 over 10.
R,
All over h.
r over h.
Well,
That's a right way to do it.
Okay, this is the same thing. H is 8 inch. 8 inch. This is the same shit. But, so we solve for r, which is down here. I wish you guys can see it. I'm just going to write it up here. When you use the algebra, you're going to get r equals 9, 10 over 8. This is our r. This is really important because we know what r is now. So now we go back to here. We still want to solve for dv dt. So you come here, you take the derivative. Well, actually, you don't need to take the derivative.
Al, question.
Yeah.
So you could have done it either way, right? You could, but you already know,
H?
yeah, you already
Yeah.
know this is H.
He just wanted to do his way.
Oh.
It would have been the same
You
thing.
however you want.
Oh, yeah. But, okay, so we know what R is with proportion. We go back to the formula, which is V 1/3 pi R squared over H. We plug in R here. It's really small, but I wish you guys see it. And then you square it. You square it, you're going to get 81 over 100, because 910 squared is 81 over 100. H to the third power, because there's an H there, that's 10 H. And so you have this V equals 1 over third pi. Cancel out by multiplying. You're going to get 27 over 100 over V. And that V equals 27 over 100 pi, H to the third power. And this is where we take the derivative, the whole function, so we can get V. Derivative of V is dV over dt, that's what we want. And then you take the derivative of H to the third power, you bring down the 3, which is 3H to the second power, and then you have dH over dt, because we took the derivative of H. And from there, you solve. We know what H is, which is 8. So we plug it in for the 3H squared here. So, and this is, and we know what dH dt is, because it's 1. We're given it. That's the change of height over time. And when we use the math algebra here, so you guys can see it, you should get this answer here.
Why didn't you just put 8 in for H?
Yeah, because you guys want to do the history.
Okay.
I would have put it in a long time ago.
Yeah.
It's the same thing.
You can.
Yeah.
Why not?
You can.
Why is that?
Because the instant you put a V equal 1 pi 9 over 10 times H, which is 8.
No, I mean, when I'm in software right now, like, 8 times 9 over 10.
You do that, take the derivative is equal to what?
Oh, yeah. Okay, you can't do that. Yeah, Jen just proved it. Okay, you have to keep the H because of the derivative.
The thing is to find an equation that is one variable.
Yeah.
And then you plug in the number to H, the whole thing becomes constant.
Yeah.
You bring the constant to 0.
Yeah. The tetrahedron.
So you can bring
So, yeah, it's equivalent. Yeah. Any questions?
Oh, and also just one thing to keep in mind. You know that right here we are dealing with 3 variables, R, H, and volume, right? The first thing they give us is a volume or dV over dt, and then second thing they give us H or dH over dt. And since they did not give this R part, the best way is to somehow to get rid of the R. That way it will make life simple.
Yeah.
The thing is this happens in every book problem. Just keep understand.
All right. So, any other questions? Do you guys want me to move on to those problems?
Yeah.